Welcome to the GWM Motor channel. This channel provides easy-to-understand explanations of car mechanisms. Great Wall Motor is a Chinese automobile manufacturer and is often referred to as GWM. With global sales of 1.23 million units in 2024, it can be said that the company is roughly half the size of BMW or Mercedes-Benz. They have adopted a highly unique series parallel hybrid system, called Hi4, for their new generation plug-in hybrid midsize SUV. In very simple terms, the system splits the hybrid unit into two, placing one on the front wheels and the other on the rear wheels. Let's take a closer look. In typical two-motor hybrid AWD vehicles, the hybrid unit, which consists of a traction motor and a generator, is mounted at the front to drive the front wheels, while a dedicated rear traction motor is placed at the rear to achieve all-wheel drive. Therefore, 3 electric motors are required. GWM's system places the generator at the front wheels and the traction motor at the rear wheels. In this video, we explore how GWM managed to achieve AWD in a two-motor hybrid system while using only 2 electric motors. Before examining GWM's system, we'll first learn how a typical series parallel hybrid system with an electric rear drive function works. Let's first take a look at the system configuration. The generator is connected to the engine. When the engine is in rotation, the generator also rotates. However, if the electrical circuit to the generator is disconnected, it won't generate electricity. The clutch is connected to the engine output shaft through a set of gears. The front traction motor is positioned downstream of the clutch. The drive force is transmitted from the front traction motor output shaft to the front differential via gears. The rear traction motor and rear differential are positioned to provide power to the rear wheels. Next, we will examine the power flow. In EV mode, the engine stops, and the clutch is disengaged. During normal driving, the vehicle is propelled by the front traction motor, which operates using power from the battery. Depending on the selected drive mode and driving conditions, the system supplies power to the rear traction motor as needed, delivering drive force to the rear wheels. When the battery charge falls below a certain level, the system operates in series hybrid mode. With the clutch remaining disengaged, the engine drives the generator. During normal driving, the electricity generated by the generator powers the front traction motor, which propels the vehicle. The engine is not involved in propelling the vehicle. Similar to EV mode, the system supplies power to the rear traction motor as needed to drive the rear wheels. Additionally, when strong acceleration is required, power is also supplied from the battery, allowing the traction motors to generate high torque. When cruising at a constant speed on the highway, the system operates in parallel hybrid mode. The clutch is engaged, and the engine output is transmitted to the front differential. The front traction motor and generator are rotated, but they do not operate because no power is supplied. As needed, battery power is supplied to operate the front and rear traction motors. To summarize, in a typical series parallel hybrid AWD setup, one of the 3 electric motors functions as a generator, one serves as the front traction motor, and the other serves as the rear traction motor. Let's first take a look at the system configuration. A clutch is positioned on the engine output shaft. The engine is a 1.5 liters naturally aspirated inline-4, producing a maximum output of 85 kilowatts and a maximum torque of 140 newton meters. Because it has a 16:1 compression ratio, it can be assumed that the engine employs a deep Miller cycle. If you're interested in the Miller cycle, please check out this video. There's a link in the description. GWM claims that this engine has a thermal efficiency of 41.5%. Let's get back to the system configuration. A generator is connected to the clutch output shaft via gears. The generator also operates as a front traction motor, in which case it produces a maximum output of 70 kilowatts and a maximum torque of 110 Newton meters. Power from the clutch output shaft is delivered to the front differential via a 2-speed transmission. To drive the rear wheels, a rear traction motor and rear differential are installed. The rear differential is equipped with a side gear shaft coupling that disconnects a wheel. The rear traction motor produces a maximum output of 150 kilowatts and a maximum torque of 350 Newton meters. As you can see, this system has only 2 electric motors. However, it is definitely a 2-motor series parallel hybrid with electric AWD. To solve that mystery, let's take a look at the power flow. In EV mode, the engine is shut off and the clutch is disengaged. It wasn't possible to find detailed information, but it seems likely that during normal driving, the system sets the 2-speed transmission to neutral to prevent the generator from rotating. Battery power is supplied to the rear traction motor, allowing the system to propel the vehicle as an RWD. By supplying electricity from the battery to the generator is operated as a front traction motor, enabling the vehicle to function as an AWD. When the battery charge falls below a certain level, the system operates in series hybrid mode. The clutch is engaged, and the engine rotates the generator to produce electricity. With the transmission in neutral, the engine output is not transmitted to the front differential. That electricity is supplied to the rear traction motor, allowing the system to propel the vehicle as an RWD. In this state, if the transmission were engaged, it seems that the engine output could be transmitted to the front differential to function as AWD, but according to GWM's video, this control is not implemented. When cruising at a constant speed on the highway, the system operates in parallel hybrid mode. The clutch and transmission are each engaged, and the engine output is transmitted to the front differential. The system propels the vehicle as an FWD. When an inactive rear traction motor is rotated by the wheels, it generates a slight rotational resistance due to electrical effects. To prevent this, the side gear shaft coupling in the rear differential is disengaged so that the rotation of one wheel is not transmitted to the differential. Because the pinions and the differential absorb the rotational difference between the left side gear and right side gear, the rear traction motor does not rotate. Audi's hybrid system also includes a device for the same purpose, but beyond that, there are not many other examples of its adoption. In the future, as manufacturers strive to further improve hybrid efficiency, we may see an increase in devices that mechanically decouple the inactive traction motor. If you're interested in Audi's hybrid system, please check out this video. There's a link in the description. When strong acceleration is required, battery power is supplied to the generator, which then operates as a front traction motor to drive the front wheels. Additionally, if the system determines that AWD is required, battery power is supplied to the rear traction motor, driving the rear wheels as well. If you were an automotive designer tasked with developing a 2-motor series parallel hybrid electric AWD vehicle, what would you do? The first idea that would likely come to mind is to place the existing hybrid system at the front and install a dedicated traction motor at the rear. In fact, although GWM's current system has unique features, such as a 2-speed transmission at both the front and rear, it is still a 3-electric motor system. However, the designer who came up with the Hi4 system was on a different level. To integrate the front and rear wheels into a unified hybrid unit, this is not something one would easily come up with. He or she must be a genius. However, whether that makes it a better car is another question. Let's leave that evaluation to testers in each country, once exports of this model begin. Thank you for watching. If you enjoyed this video, please consider subscribing to the channel. We'll see you in the next video.